Okay, I wanted to show a couple things here before I get started. I use at my facility, I use spiral wound gaskets, which is what these are. They're my most common thing I use. We also use on a couple fittings, but mostly on the 150-pound flanges, we'll use compressed fiber gaskets. But this is what a spiral wound looks like for 3-inch. There's one for 4-inch. And I use the same threaded stud size for 3-inch and 4-inch, and it's a 3/4 10 by 4.5 inches. It's great for 4-inch flanges, but it's a little long for 3-inch flanges. But I don't want to carry two different sizes. The grade is, you can see it there. It's essentially it's a B7. And then same thing here on the 5/8. This is 5/8. So for 2-inch flanges, it takes a 5/8 threaded stud, and this is 4 inches long. And then we just use standard grade 8 zinc covered, zinc coated nuts. I've been a few places where they'll use a structural nut, which is just a fatter nut. There's a few incidents, a few places where we'll put a nut, and this is about as big a size nut as I can get on some of them. A structural nut is good if you've got a lot of open space. And these are called spiral wound gaskets. Here's what a used one looks like. It is, should be able, if I can hold this right, this thickness in here is what we end up compressing. Is this part right in here gets compressed, and you can see where this has been grooved by the flange, and then how the center part's been compressed. And that's your seal is made right here. And this is what they look like if the inside gets sprung out. That's really all it is. Just wound up metal inside there that compresses down and makes your seal. I'm still using this metal-free 2000, and it works really good on the studs. It works really good on the bolts. You can use bolts as well. Just use a grade 8 zinc bolt. It'll work fine. I use the grade 8 bolts when I have to. Otherwise, I prefer to use the studs. They seem to tighten better, tighten more evenly. I've also been using, I bought last year this Jet Lube Silver Plus regular anti-seize. It is really good stuff. I think as soon as I run out of this stuff, I'm gonna be switching over to that. I'll put links below the video for all of these items except for this one. I already got one video where that's in there. And then I'm also going to add a link to a brochure from a company called Flexitalic, and they make these. They didn't make these particular ones, but they make these spiral wound, and they make compressed fiber gaskets. And it's an excellent manual. It's got a lot of references. And matter of fact, I'm going to pause this here in a minute, and I'll show you what I use for a printout. But when it comes to tightening them, tightening your studs, I use wrenches, and then I also use this Milwaukee 1/2-inch impact. I like this one. One of the things I like about it is I've got 3 power settings here in forward. And when you tighten your bolts, you do it 3 times. You do 3 different torque ratings in a pattern, and then you do your 4th round, which is just tightening it up. So I do my first round at setting number 1, then 2, then 3, and then I do my last final round on setting 3. These things need to be torqued down to a certain torque value. I've followed up behind this and behind using just my wrenches in the past, and I've always fallen right in the torque range for my final setting, so I don't use a torque wrench anymore. I just follow my same practices and I get consistent results. So again, like I said, we'll be clipping parts in here, so that's it for now. Okay, I wanted to shoot a video going over some changes I'm making to my property, and I wanted to go over my custom-made 100-pound cylinders that I use for draining liquid out of piping, so I don't have to vent all the liquid straight to the atmosphere or try to find some other place to put it. What I'm doing is, we have these mass flow meters, and they've failed us. They've given us a lot of trouble and they failed us, so we're switching over to this over here. It's an LC, positive displacement meter, and it requires that I change my piping. So from my differential valve here all the way to my vapor eliminator, I've got to replace my piping. I've got to redo it. And so on this line here, I went to a 4-inch swing check, and then I also installed that's where my hydrostat is installed over there, and I got a drain valve there to drain this part of the piping. That's my model number of this 4-inch positive displacement, and this will be where the electrical wiring will hook up. And I'm in the process of getting ready. I took the plug out of here. I'm going to use this to fill this meter 100% up with liquid when I'm ready. But what I need to do here is I need to drain this line. And I'll start here in about an hour, but I wanted to show you here what I do. I bought 2 regular 100-pound cylinders. I took the valve out, and then I replaced it with Schedule 80 pipe fittings, Forge T, some other Schedule 80 here, and I installed a full port ball valve. This is a little strainer, and this is a female POL connector. I installed this strainer just to collect, in case there's a couple pipes I have that they can collect Teflon tape and sometimes some scale, so I'll catch it in here before it goes into my cylinder. And to clean the strainer, this union, I anti-seized it, and then it's only on hand tight, so I can just break this off by hand, turn the strainer upside down, shake out anything that gets caught in it. And then I installed, this is a Marshall valve. Can't remember its valve number, but here's where I installed a vapor relief valve, and here I went, and we're going with a bigger little bleeder valve. It's far bigger than the bleeder valve comes with a standard 100-pound cylinder. And the nice thing about this Marshall valve is that just like the 2 sides are tapped for 1/4-inch female pipe thread, the bottom of this valve is also drilled and threaded for 1/4-inch female pipe. And so I put a swage lock fitting in there and a short piece of swage lock tubing, so that this spit valve is tied in with that dip tube, and it goes off somewhere right around 80–85% of the capacity of this cylinder based on its height and everything. So I'm close. And then I leave this on. And then I added a couple braces, and I added this collar because this sits up higher. You can see how this sits up higher than the original construction collar. So I installed this to protect the valve. And then all I do is I'll run a hose from here to this drain valve. And then because I've got a back check in here, and because this 4-inch here and this eliminator, it sits a little bit lower, I'll run a hose from here into that other cylinder right there. And then all I need is a POL by flare adapter, and then just regular flare fittings. And then I just use regular 3/8 LP gas hose. I really have two reasons I wanted to do this video. One was to just show you how I drain a section of piping so I can recover all of the liquid, and then the vapor I just release into the air. Also, if you are not familiar with, or if you've never done flange connections, I just want to show you what I do, show you how I do it. Whether it's what you do at your place or not, or like I said, if you've never done it before, it'll give you an idea of what's required to make a good connection. So I'll be stopping and starting this throughout the day, so hopefully we can edit it to where it doesn't seem quite so hectic. But okay, I have my 100-pound cylinders hooked up. As you can see, I'm running from this drain valve here, and then I'm going to this, and then of course I've got my back check here. I want to drain all of this, so we're coming from the bottom of the eliminator strainer, and this is my liquid coming into the strainer, so I've got it locked out. This is my coming out of my eliminator, so I've got that locked off as well. So that shuts off all of my propane, liquid and vapor, going this way. So I'm just going to open this one up. I purge this line as soon as I hook it up at this end. I crack it open, push all the air out, and then I use this bleeder here. I just open it all the way up, and that allows propane, as we push the liquid in and the liquid just sprays in here, this gives the vapor a place to go when it starts building up pressure, and that is what will allow this cylinder to load and fill up fairly quickly, a lot quicker than the standard valve ever could. And also, I can get away with doing this, changing all of this, because these cylinders never leave my property. I just keep them here. They never get sold to a customer. They never go for anybody's use. I still have all my protection here, but it just, since I'm using non-standard fittings, it just never leaves my place, so have no issues at all. So now all I gotta do is open this up. And let it run. Now we'll do the other side. Yep, got a leaker. Since we're just draining this, we're not looking for zero leaks. We're just looking for nothing too big. And we'll drain this. Let's open this up. Now it's just a matter of time. I have to go move rail cars, and I'm going to give this some time. I've gotten the rest of my property kind of bottled up to where nobody can drive in here while I'm doing this, because done loading trucks till I get this fixed. So that's it for now. Okay, I have my piping apart now, and so what I'm getting ready to do is I'm getting ready to mount my back check, my swing check here. Like I said, there is a attachment that's going to be in this video, and it's going to be for Flexitalic guide, Flexitalic guide, and it's a digital version. And what I do is I went and I printed out this one page here. It gives you your bolting diagram and your bolting pattern for 300-pound 8-bolt, and then it's also got all the way up to like 28 or 32 bolt patterns. And so what I do is I just printed it out. I printed out 2 or 3, and then I just went to Staples and had them laminate it. And so I keep this around all the time. And so it gives you your bolt pattern. So what I do is I'm just going to start marking this. This one was marked earlier, so we're going to be 1, 8, and then be 5, 3, 7, 5, 3, 7. Then we're going to be 4, 6, 2. And let's see, 4, 6, and 2. I'm going to mark over here. I'll probably put 6 over here too, just so I can end up seeing it as I go. As a rule, your most common, at least the most common flanges we use, are either a raised face like this. This is a raised face. It's raised a 1/16 of an inch, or you just get a flat face. And our spiral wound gasket will line up in here, and it'll mate up onto this face and mate up onto my back check valve. And also, let's get over here. This is just a filler. This right here is a filler. So when you drop it down in there, it lines itself up, and it will line this up with both of the faces. So normally what I do is you get the 4 bottom ones in. Hold on. You get the 4 bottom ones in, and then while it's real loose, you drop this in from the top, and then you put the rest of your bolts in. That's normally how I do it. So that'll be it for this section. I'll come back when I get a little bit farther along here. Okay, I've got this kind of roughed in here, my back check, my swing check valve. And so I've got it all in. This is a flange support bracket right here. I drew this up, and my welder made it for me. It's going to support the weight of this swing check and this vapor eliminator here. Whereas I used to have 2 others anchored in the concrete here, this one's going to end up supporting it. I still got it braced here with a boom truck, so I've got that held in place. And so what you want to do is you want to make sure that you're flush. I mean, these aren't going to be perfect, they're going to be off, these castings are going to be off, but you want across here, across the side, so essentially at 12, 6, 3, and 9 position, you want this to be even. And when you begin tightening these up, you need to make sure that these flanges are square to each other. So what I do is I take a reading with the tape measure here about 8 o'clock, 12 o'clock, and 4 o'clock, so that, you know, if I'm taking my reading here, here, and here, that those 3 spots right there will keep me square. And you need to be within a 1/16 of an inch or less on your measurements, so they need to come in, you know, pretty square, pretty tight, to make sure that you're squeezing down, you're clamping down evenly, and then you should have no leaks. So I'm going to shut down here and get working on this. Okay, it's the next day. I had to shut down yesterday and hurry up and do my work because this rain was coming in. So went ahead and finished putting all of my piping together. I've got everything installed. We've done a pressure test and we've leak tested. So a few years ago, I was on a job site helping some guys out in Wisconsin, and I saw a welder do this trick, and I've been doing it ever since. And you just take tape. I use gaffer tape, but you can use duct tape or even 2-inch wide electrical tape. Wrap your flange all the way around and just rub it down, get a good seal. And then take a small screwdriver. I did an ink pen, and you just punch a hole in it. So when you go to check for leaks, you just spray your leak detector right over that hole. And if anything's leaking, it'll just come bubbling out of there, and you'll know right away. So I went ahead and did all of them. Checked the rest of my fittings, sprayed them all down, and we're good to go. I know it was kind of rushed a little bit yesterday. There's some more things I wanted to share, but when you are putting these together, getting your flanges together, normally what we do is we draw everything up finger tight and then try to get it as level as we can across the top, bottom, and both sides. So you like your 4 points, north, south, east, west, you try to get them as lined up. But each manufacturer is going to be slightly different. So it's not like these are all, you know, within 1/8 of an inch of each other as far as diameter, but you just get close. And then you measure, like here at 8 o'clock, 12 o'clock, 4 o'clock, and get it close. Try to get within 1/16 of an inch, because generally on a 4-inch flange, it's usually about 2 3/4 inches is your gap here. And then do one tightening in a sequence. So you go and tighten it 1/3 of the torque all the way around, and then take your measurement again at 8 o'clock, 12 o'clock, 4 o'clock. Then you do your second tightening sequence, and then we usually take another distance reading, and usually it's about 1/16 of an inch below, so that's 2 7/16. And then once that's done and you prove that you're square, then you just tighten your third tightening pattern and then do your fourth in a circle, and that's it. It's not uncommon that you'll have to use pry bars or a jack or a lever and a fulcrum or something, you know, to get these just right. And this piping system was put together for a totally different meter setup. Everything was different when it was built. So now that we're changing all of it, it both lines up and does not line up. So we ended up here and here had to use ratchet straps to pull this piping this way, and then I used the crane to raise up, excuse me, lift up on the piping, take some of the stress off, and then we pulled it this way to get this flange to go square. That's not uncommon to have to do something to manipulate these to where you can get them all square, but that's the trick. Once you get them square and you can prove on those 3 different points of measure that you're even, then you'll be square, and you keep tightening it up and you just keep checking your square, and then you should have no leaks. And then I think that's it. I think that's all I wanted to show on this. So this is how I do it. If you've never done it before, or you're getting ready to go do it, you know, haven't done it before, this is one way to consider about doing it. But of course, if your company has written procedures for how to do it, you have to obey whatever the written procedures are. So I hope this was helpful. Hope it might have shown you something that you normally don't do. So thank you.